by training, and did a PhD in aerospace engineering. And since then I've been working for about 20 years on applied physics, trying to develop measurement methods for complex environments, diverse range. Typically those would be optical techniques. In AirPROM we try and we are working on developing a physical model of airways of specific people. So that will turn into models like these, which is an airway model based on a CT scan, which allows us to study the flows occurring in these airways without having to go to an actual person and disturbing that patient. So an AirPROM is about looking for what causes asthma and COPD and the processes that occur in asthma and COPD. So in AirPROM the word model is used quite a bit because we look at very different aspects. Now the thing that is common in asthma and COPD is that people get narrowing of airways, get a different composition of the airways, and also have get a different shape of their airways. And that all influences the progression of the disease. There's people looking at mathematical models, modeling airways as basically a tube surrounded by an area that they can apply pressures to or other things. To model what these airways will do, whether they will deform, whether they will narrow, so you can model the effect of the muscle increase and of the increase of the wall thickness, for instance, as is common in COPD and asthma. There's other models that are CFD models, where we model the flow going through an airway, and that way, if we take a CT scan of a person, we can then model, see what the flow would be, we can predict how the flow would behave. So that means that the person comes to a CT scan, takes a CT scan, get a CFD, and we know what the flow does. The problem with that is that CFD is not perfect. It's a simulation of reality, and you have to make some approximations. So in order to help develop those CFD models, computational fluid dynamics models, to measure, to know how the flow behaves, we in our group are developing measurement techniques for those same airway geometries. We can do the measurements very accurately, and we can compare that to CFD, and that way help develop the CFD models. We take a CT scan of a person. From the CT scan we extract the geometry of the airways. From these airways, from that computer model of the airways, we can either use that as input for CFD to see the shape, to calculate the flow through that shape, but we can also use those same models to make a 3D printed version of an actual airway model, such as this one. In the 3D printing, we take that computer model, and the 3D printing puts down a layer at a time of the actual geometry. So in the end we are left with a model such as this, which is hollow, and the inside of this model actually represents the inside of the airways in an actual human being.